All right, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hopefully you guys have had an okay week so far. Let's actually jump into it. There we go. And let's make sure that I can see the chat and who's coming in. Okay, awesome. All right, so let's begin. As always, let's start off with some public service announcements, things that you need to know for the coming week. So next Tuesday is election day, so the college is closed. If you so desire, that is your day to get out and vote if you haven't voted early. Yeah, no school on Tuesday. So that's the first thing. The second thing is our next class. Our next class is on Monday, and for that class, you will have a quiz. So quiz number 4 is on Monday. You should, by the end of today, cover up to lecture 16, and that's what the quiz goes up to lecture 16. So the quiz focuses on 14 through 16. And I'll talk a little bit about that later on, actually. So our next Zoom class like this is next week, Thursday, and we'll go over the quiz at that point. Let's actually talk a little bit more about the quiz. Okay, so as always, the quiz is on Gradescope. So at the beginning of the class period, just log into Gradescope and you take the quiz. Same deal as always. The sections that this quiz covers. I saw late last night, that there's somewhat of a typo here. I meant to put the quiz from lectures 13 through 16, but I noticed that the syllabus said 14 through 16. And so what I would say is that I'm still going to leave it on sections 14 through 16, and what I would have asked you from lectures 13, I will put in the bonus. But at this point, you guys have seen questions like that over and over, but I'm not going to punish you guys for my typos. So those are the questions like with distance and midpoints and circles and things like that. So you saw those on the last quiz and the bonus. You saw it also on the first test. And so I really wanted to put that stuff on an actual quiz, but I didn't type it up. So I will put that again in the bonus. So hey, if you got it wrong, questions like that wrong the first 2 times, you had a chance. Now is your 3rd chance on that. Quiz is on lectures 14 through 16. Roughly speaking from the textbook, this covers section 1.10, 2.1 through 2.4, 2.7, 3.1, and 3.2. There is a small part of section 2.2 that I did not do in these lectures that I cover in lecture 17, and that was piecewise functions. So that would be in the bonus section. But other than that, everything from in these sections are covered. Okay, as for the topics that you want to focus on, equations of lines and their slopes and their graphs, I assume by now we're all good with those. You've also seen a couple of those on bonus problems, and in general, students are kind of okay with those. We also go further in with quadratic equations. So you should know how to solve quadratic equations, how to find vertices of quadratic equations, how to graph quadratic equations. So that's the second thing. Also, we did talk about graphing general polynomials and finding their end behavior and that sort of thing. Should be good with that. We also introduced the notion of a function. We've been using functions for a while, but this is the first time we've officially introduced them. And we spoke about what a function is, different ways to represent functions, and how you would interpret these representations. We also talk about function operations. How do you combine 2 functions? How do you add them, multiply them, subtract them, divide them, as well as how do you, quote unquote, compose functions. So function composition was also discussed. Again, some that we've seen before in this class, but it's now officially defined, as well as I go over something called the average rate of change, which is actually equivalent to the difference quotient, but in just a slightly different context. So those were the things that were covered throughout these lectures. So that's what you would have to know. Now, if you're pretty comfortable with all of those and you want to have a shot at the bonus problems, so you would be studying things like piecewise functions, transformations of functions. That's like when you're shifting things, inverse functions and their graphs. That's sort of what I would put in the bonus section, as well as, like I said, I'll throw in a bunch of problems from section 1.9, like distance and midpoints and circles and things of that sort. So that's what your quiz essentially is going to look like. So now, before we move on, I just want to sort of open up to any general Q&A. Any questions that you guys have on these things or other things from the class, we will start with those. Questions, concerns, comments, issues?
What?
Hello, Stephanie, were you saying something or did you?
What homework question? I mean, what homework number are we supposed to be on? Like what lesson?
The homeworks go by the sections, so I have the listed sections there. Right, so if you go in the homework, you'll see the chapter and the section. So you do the homework based on those sections. So you should be doing you should be up to like section 3.2, except at this point you would skip 2.6 and 2.8 because that's not done. So you do everything in chapter 2 except 2.6 and 2.8. I don't think we do 2.7, but you can check the syllabus for that. But it's the listed sections there. So the homeworks go by the sections. Any other questions? Any questions on the topics that I mentioned here that the quiz will be on? Maybe you're watching the lecture, something you didn't understand, something you want to talk about. No? We understand everything? So everyone's getting 100% on the next quiz? That's awesome. That's what's gonna happen. Okay.
Will we be provided graphs, or do we need to sketch our own graphs?
So it's a quiz, so you won't have to sketch your own graph, but you should know how to sketch it. So I'll either give you a graph and you'd have to identify the equation, or vice versa. I can give you several graphs and then you have to, let me start. I can give you an equation and several graphs and you'd have to match the equation with the graph, or vice versa. I can give you a graph and several equations and you'd have to match it with the equations. So either way, you should know how to sketch a graph or at least recognize a graph based on the formula, but you won't have to actually sketch it specifically yourself. So on the test, you would have to do that, where you can upload your work. But because I'm not asking you to upload your work from the quizzes, so any pictures, I will provide them, but you would have to either match a picture with an equation or match an equation with a picture, something of that sort. So when it comes to the graphing, that's how it would be tested on the quiz. Other questions? Okay. Maybe let's just go over some of the basics of some of these just to see. But because you guys have no questions, I'm sure you know all about them. What I will do is, because students are usually very familiar with these and usually don't have any trouble, and you guys obviously don't have any questions anyway, I'm going to assume these two are okay. Everyone's okay with those guys, equations of lines and the difference quotient and average rate of change, because those are just formulas, the second ones, and we students tend to be very comfortable with equations of lines. So let's actually talk about the others. Okay, let's do quadratic equations, their vertices and their graphs. So let's do some concept checks here. So let's talk about solving quadratic equations. So given an equation, say ax squared plus bx plus c equals 0, and your a is not equal to 0, how would you solve it? Right? So I gave you this random equation. What is the strategy? How would you approach it? What would you do? Hello? How would you actually approach, if I gave you a quadratic equation, what do you do? And ask you to solve that equation.
You can factor out to find the X-intercepts.
Okay, so you can factor the left side. Okay, and after you factor, what would you do?
You find the Y-intercept and then you plug points in and sketch.
I didn't ask you to sketch. I asked you to solve the quadratic equation. So if I gave you this equation and I asked you to solve for x.
You can use the midnight formula.
The what formula?
The one with the discriminant.
You mean the quadratic formula?
Yeah.
Yes. Probably not the first way I would have done, but yes, you can. So in general, what we would do is we'd factor the left side and set each factor equal to 0. So you apply the 0 factor property. Or I would say as a third option, if the left side does not factor, use quadratic formula. And yes, I did mention this always works, right? So it'll also work on the ones where we could factor as well as the ones we can't factor. Always works, but it can be overkill. right? So, I mean, if it can factor, I wouldn't worry about using radicals and getting involved in this huge formula. So I would rather you approach it by first trying to factor, and you kind of resort to the quadratic formula if you realize that you can't factor it. Another option is completing the square. I would not recommend you complete the square. You do have to know how to complete the square for other scenarios, but I wouldn't really recommend completing the square in this scenario. One, completing the square is this method that gave us the quadratic formula. So if you're going to use the quadratic formula, completing the square is kind of like a reinventing the wheel thing. You just have to work much harder than you have to. While it's another option, I wouldn't really recommend it. So I would probably say you see a quadratic, a random quadratic, I ask you to say it's equal to 0, and I ask you to solve. First thing I would try to do is factor, set each factor equal to 0. If I realize it doesn't factor, then try the quadratic formula. And we've gone over factoring, so I'm not going to explain that anymore. But that's essentially the approach you would take in solving a quadratic equation. Let's say ask you to graph a quadratic equation. How do we graph? So I gave you like y equals ax squared plus bx plus c. How do you go about graphing it?
You find the X-intercepts and then the Y-intercepts by setting like X-intercepts, you set Y to 0, and then the other way around by Y-intercepts.
Right. So first thing is to find the intercepts. You find the X-intercepts. This means you set y equals 0, solve for x. Discuss that above. That's exactly like solving a quadratic equation. So, you can factor or you can use a quadratic formula or whatever, but you need to find the intercepts. The y-intercept, well, there's only ever going to be one y-intercept for a function, right? Like now we know that the a quadratic is a function, and functions pass the vertical line test, so it can only pass along a vertical line once. So there's actually only going to be one y-intercept. And for this, you set x equals 0, solve for y. Okay, what do you do after that? You find the intercepts, then what?
You find the slope.
The slope for a quadratic? You don't know how to find the slope for a quadratic. That's something you talk about in Calculus 1. We also don't need to do that to graph a quadratic equation.
Would you need to find the vertex?
No.
Do you plug them into the equation?
Plug what into the equation?
The x and y intercepts.
Well, no, we know if we plug them in, what would happen, right? If I plug in the x-intercepts, I would just get the output 0.
Oh, right.
And all that stuff. Right, the focus is graphing. Remember the goal. So we found the intercepts. I want to draw a picture. What is the next thing I do?
You plot the points in the graph and then you just like draw it.
Yeah, plot the intercepts. And draw a parabola through them. So let me get, and of course, there are a couple things we can do here. We know that if your A is greater than 0, then you would draw something that looks like that, opening upwards. If A is less than 0, then you would draw something that opens downwards. But that's actually going to be, that will be obvious when you have all three intercepts. So as an example, let's say, say we have X-intercepts. Let's say it's 1 and 3. And let's say we have Y-intercept, Y equals -2, whatever, right? So once I actually find those, which we now know how to do, I would just go, and I'd realize it would have to look like this, right? So even though I don't know the equation, I know that this one is going to be upside down, because when I plot all these points, 1, 3, and -2, I would need to draw an upside down picture to do that, because if I drew a right side up picture, it would miss the Y-intercept, okay? So what I wrote in green is just an extra check. Technically, if you get all the intercepts, you don't actually even need to remember that. You just draw a parabola, just draw a big smiley face that passes through all the points. There is a very important issue that could arise though, because we know that when we're solving a quadratic equation, the most general way to do it is the quadratic formula, which has a radical in it. And there's a possibility that what's under the radical is negative, which means that we will not have a real solution, which means it's possible that our graph will not have x-intercepts. So this brings us to a third case. Someone got kicked out of the room. Let me let them back in. This brings us to a third case. What if we do not have x-intercepts? You'll always have a y-intercept. In fact, the y-intercept is always going to be c, right? You have an equation. You have something that looks like this. If you plug in x equals 0, you'll always have a value. You'd always get c. But it's also possible that if you plug in y equals 0, there is no x value that will actually make that true. So that's possible. So let's say I give you a random quadratic, ask you to sketch it. However, when you try to find the x-intercepts, there are none. Like you can't factor, use a quadratic formula, and you get a negative under the radical. How would you go about sketching it now?
Would you just do a dot in the y?
Right, but so that gives you 1 point. So I mean, if you get a dot on the y, how does that tell you how to draw a parabola?
Then maybe you would draw it above the x-axis or below.
Well, it can't be below because it wouldn't cut that, but there are a couple different ways, right? You can have any parabola going through this point. Right, so 1 point isn't enough.
Would you look for the vertex to see which way will it go?
Here's where you find the vertex. Come on, I asked you guys for questions and no one was asking me questions, but it's clear that you guys aren't on top of your concepts. Did you guys watch the lecture? Hopefully you did. You would find the vertex. How do you find the vertex?
X equals negative b divided by 2a.
Right, so the x value for the vertex would be negative v divided by 2a. Then you can plug this in to find the y. Okay, so that's one way to find the vertex, very computational. There's another way to find the vertex, or you can complete the square. So this means that your function would now look like this, or something like this, where there are going to be some numbers here, h and k, and then the vertex is going to be h comma k. Right, so you have two options here, but either way, if you don't have any x-intercepts, the next thing you would do is you would find the vertex, and then using the vertex and the y-intercept, you'd be able to sketch the parabola. Here's an example. Let's say I ask you to sketch y equals x squared plus 2x plus 7. So you go in, you try to find x-intercept. So you want x squared plus 2x plus 7 equals 0. Doesn't factor, so you jump in and you go, oh, quadratic formula. Minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. You'll notice here this negative. Hence, no x-intercepts. Okay. However, the y-intercept you can always find. Y-intercept is just going to be 7. But now that you have no x-intercepts, you'd go with the vertex. Now for the vertex, you can have one of two methods. One, either you say x is equal to minus b over 2a. And so in this case, that would be minus 2 over 2 times 1. So your x is minus 1. This means that your y is going to be minus 1 squared plus 2 times minus 1 plus 7. Is that what I, yes, yes. Right? So that is going to be 8 minus 2. So that's going to be 6. So here you can get that the vertex is minus 1 comma 6. Another way is to, given this function, you can complete the square. We know that we need the term here to be 1/2 the coefficient of x. We're going to square that. And then if I were to multiply this out, I would get a plus 1 as the constant term. To get back to the 7, I need to add a 6. You'll notice that this, of course, you note that this is y equals a x minus a minus 1 squared plus 6. And so you can see that your h is a minus 1 and your k is a 6. So you can find a couple ways to find the vertex, right? Completing the square, or you can use the minus b over 2a formula. Okay, now that you've done that, you can draw a picture. So we have this, our y-intercept was 7. So let's just put a point over here, call that 7. And now I just found the vertex. The vertex is at, say, 6, comma, -1. So that's the vertex. And so now I know that this graph should open like that. And so that's going to be the picture. So that's how you go about graphing, both in the case where you can find all the X and Y intercepts, as well as the case where you cannot find the X-intercepts. So in either case, you shouldn't get stuck. You shouldn't not know how to graph. So that actually covers quadratic equations, their vertices, and their graphs. Let's look at graphing polynomials in general. Okay, so tell me about graphing polynomials in general. So y equals p of x, a polynomial. How do we graph it?
You'll find the zeros or the roots.
Right. So again, step 1, you find the intercepts. Again, you find both the X-intercept and the Y-intercept. Same as above, set y equals 0, solve for x. And this here set x equals 0, solve for y. Okay, once you do that, now what?
You plug in the numbers between the zeros.
Mm-hmm.
See if it is going above or below the x-axis.
Test values between. Let me, maybe I'll be more specific. Test x values between the x-intercepts to see if graph is above or below x-axis. Okay, so once you know that, what do you do?
You figure out the end behavior.
You don't need to. Optional. You can determine the end behavior. Now, if I ask you for the end behavior specifically, then yes, you have to determine it. But in general, if I just give you something and say sketch it, you don't need to find the end behavior. You can determine the end behavior. It will save you some work in step 2. Right. The end behavior is just telling you how the ends are behaving. Is the end above or below the x-axis, right? So you can actually just test the ends with numbers and you'll actually automatically know the end behavior. We're going to talk about end behavior because it is something you should know how to find specifically. However, if I just ask you to sketch something, technically you don't need to find the end behavior. But whether or not you find it, you now know all the positions of where the graph should be. What do you do?
You plug in the points. on the graph?
Plug,
The zeros.
well, if you plug in the zeros, you know what you'll get. You'll get zeros.
No, on the graph.
Oh, you mean plot.
Yeah.
Uh, so plot the intercepts. Then what you do is you'd sketch the curve passing through all intercepts that obey the positions found in step 2. Okay, and that's basically how you go about graphing something. So let's say example, sketch. Someone got kicked out of the room again. I'll let them in. Say I ask you to sketch y equals -4 times x squared minus 1 times x plus 3 times x minus 5 squared. So let's say I ask you to sketch that polynomial. Okay, so the first thing you would do is you would find the intercepts. Okay, tell me about the x-intercepts. What are the x-intercepts?
I'm sorry, I mean -1, +1,
Mm-hmm.
-3, and 5.
What are the y-intercepts? Hello, you guys still there? Y-intercept.
I got 300.
How?
I put it in the full format.
You put it in what format?
I basically just expanded the whole thing.
You expanded everything. That's one way to do it. That would take a lot of time though on a test or a quiz. Not recommended. Go back to the concept. What does it mean to find a y-intercept? How do you find the y-intercept?
X will equal 0.
You plug in x equals 0. So you just have -4 times -1 times 3 times -5 squared. Right? So that's this here. So this is just going to be 25 times 4, which is 100 times 3. So you get 300. A lot quicker than to multiply this out. Because you multiply these out, you'd have to expand the x minus 5 squared. You get 3 terms there. And then you'd have to like multiply out like a binomial, and then you get 3 terms there, and then you have to multiply out 2 parentheses where there are 3 terms each. Like it'll take forever. Just remember the concepts. This is the power of knowing about concepts. It can save you a lot of work and hence cause you to not make any needless errors. So yeah, the y-intercept here is 300. Okay, so that was the intercepts. And intercepts you should be able to do very quickly. You should be able to just look at this and know what the x-intercepts are and do minimal calculations for the y-intercept. You just know, just plug in all x equals 0, and that'll give me the y-intercept. Okay, so now what you're going to do is you're going to do that whole plugging in numbers in between these guys. Now you can plot the thing at the same time. So let's actually do that. So let's say you're here, and you have -1, 1, -3, and 5. Okay, so you have, say, a -1, you have a -3, you have a 1, and you have a 5. Are those all? Yes. Okay, so now you're going to just plug in numbers in between these guys, right? And so I can pick a number over here, say -4. I can pick a number over here, say 6. I'm going to write those as different colors on purpose. I can pick a number in here, say -2. Pick a number in between these two, say 0. Pick a number in between these two, say 2. It doesn't matter which numbers you pick, you just pick some numbers, right? And now you're going to plug those numbers into the original formula. And basically, what you care about is the sign, okay? So for 1, I know that the 4 is always going to be a negative influence, and the x minus 5 squared is always going to be a positive power. So now I just have to figure out what are the signs of the other two. So notice that if I were to plug in -4 into this would be positive, and that would be negative. So overall, I get a positive number. So I know the graph should be up here. So I just mark X marks the spot. Moving on to the -2, I plug in -2 here. That's positive. Plug in -2 here. That's also positive. So now I'm negative. I know I should be below here. If I plug in a 0, I already actually know what I should get. I should get a 300, but you can actually realize that that is going to be, if I plug in 0, this would be negative, and this would be positive. So I know it's positive. In fact, I know where it's going to be positive. It's actually going to be positive at 300. Right? I actually already know that. Now I go and I plug in 2. If I plug in 2 into the first one, I would get a positive number. Plug in 2 to this, I get a positive number. So now I'm negative, so I know I should be below. If I now plug in the 6, 6 squared minus 1, that's positive. 6 plus 3, that's positive. So now that is below. So now notice that I know where my graph should be. On the far left, it should be above. Then between -3 and -1, it should be below. Then between -1 and 1, it should be above. Between 1 and 5, it should be below. And for greater than 5, it should also be below. Now I know all the relative positions of the graph based on how it behaves around the intercepts. So now this brings us to step 3. And why I did the -4 and the 6 in different colors, I just want you to appreciate that using end behavior would have helped us find the green X's above. But as you can see, I already knew how to find those green X's. So end behavior was somewhat optional. I will talk about end behavior after this, but when it comes to graphing, I didn't need it. So now, what do? You go in and you just draw the picture that passes through all the intercepts. You definitely need to make sure you pass through -3 on the X, -1 on the X, 300 on the Y. You need to pass through 1 on the X, and you need to pass through 5 on the X. But other than that, you're just going to obey where you should be on the graph. So I know on the left, I should be above, but I need to come down and hit that. Now I need to go up and hit that. Now I need to come down and hit this. Now I need to go back up to hit the 5, but I need to stay down because according to the 6, I should be down like that. And so that would be the graph. Now, it is worth mentioning here, we don't know exactly where the maximum is. We don't know. Right? Is the peak on the y-axis, or is it a little bit to the right or a little bit to the left? We won't know. It is true that for quadratics, the vertex, if you have 2 x-intercepts, the vertex is always in the middle between them. So you might guess if this were a quadratic that went through -1 and 1, you could know for sure that the vertex would happen on the y-axis. However, in this case, it's not a quadratic, and that does not work if it's not a quadratic, right? So I don't know exactly where the peak is. It could be a little bit to the right or to the left of the y-axis. Or on the y-axis, we don't know for sure. In Calculus 1, you'll actually find a way to figure out for sure. But so far, this is all we know. This would be good enough for a sketch. So you would either sketch this in your work, or you'll pick the answer choice that most closely fits this picture. But that's how you go about graphing. Let's talk about end behavior. Tell me about end behavior. How do we determine end behavior? I give you a polynomial. Tell me about the end behavior. How would you figure it out?
It depends if the highest power is odd or negative, and if the base of the highest degree is positive or negative.
The base? I think you're calling things by the wrong name.
Like x of n, if x was positive or negative.
No, you don't look at if x is positive or negative. You mean the coefficient of x?
Yes.
Because the x can be anything. If it's a polynomial, you can plug in anything for x. It can be positive or negative. It's not going to matter. It's not going to affect the end behavior. What you look at is the degree. So for end behavior, you look at the degree of the polynomial. This is just a fancy way of saying the highest power. And the leading coefficient. And things kind of break down into whether the highest power, so let's say So let's say your y is ax to the n plus a bunch of other stuff, right? So, and this is the highest power. It breaks into two parts based on whether your n is even versus whether your n is odd. So let's look at these two separately. So let's say now your y is equal to ax to the n, and let's suppose your a is positive, right? So you have an even power and you have a positive leading coefficient. It means the n behavior, both ends would point up, right? So here the n behavior is, you'd basically say, a way that this can be described is as x goes to infinity. As we go far to the right, the y value will go up. And as x goes to the left, the y value will also go up. So it goes up in both cases. You can be in a scenario where, you would have y equals ax to the n plus a bunch of other stuff, where your a is negative. And if your a is negative, everything just flips upside down. So you'll have both ends going down in an even graph. So as x approaches infinity, your y values will go down. And as your x approaches negative infinity, your y values again go down. So that's the even case. For the odd case, both sides do something different. Specifically, when the leading coefficient is positive, the right side goes up and the left side goes down. So you can describe that by, as your x goes to infinity, your y will go to infinity. And as your x goes to negative infinity, your y would go to negative infinity. Or again, you have an odd power, but the coefficient is negative. Then everything flips on its head. The right side would go down and the left side would go up. So you would get, as x approaches infinity, your y approaches negative infinity. And as x approaches negative infinity, your y would approach infinity. Let's look in our previous example. Let's look back at the previous one and let's re-examine the previous problem, but in terms of end behavior. Where are we here? All right, tell me how to identify the end behavior. So what if I gave you this and instead of asking you to sketch it, I rather ask you, tell me about the end behavior, identify the end behavior.
Would there be 3 roots in this case?
3 roots? What do you mean 3 roots?
Like crossing the x-axis. So like you have a point at -1, -3, and +5.
No, and we already did the roots for this. We showed that there were 4 already, plus or minus 1, -3, and 5. We already found the roots in the previous example, right? These were the roots. Here, I'm asking you about end behavior. We're focusing on end behavior here. Has nothing to do with the roots.
So wouldn't you have to distribute to see what the highest power would be? So you can see how the end behavior would go.
Okay, so we already spoke about distributing. It would take a very long time to actually multiply everything out here. Give me a shortcut. You don't want to waste your time multiplying this guy out. Take forever. And you might even make a mistake after it's all said and done. What's the easy way to see what the highest power is here? Right, like if I were to multiply this out, I would definitely get a minus 4x to what power?
X to the fifth.
X to the fifth. How did you get that?
I just multiplied the x to the second times x times x times x.
Okay, can you give me a short rule? What you can tell someone to do? How can you think of that 5?
Is it the LCD?
LCD of what? It's not the LCD. You would have to be multiplying out, right? So that's what you're doing, right? So you're going to be taking like and you really you don't care about all the trails, because when you're talking about end behavior, you only care about the highest powers. So what you want to imagine is multiplying out the highest powers of all the x's. What does that mean? Like if I start multiplying x's, how do I get the new powers?
I mean, if you're multiplying the x's, you're adding the powers.
You're adding the powers. So that 5 is the sum of something. What is the sum of?
The power of all x's.
Sum of the highest powers in each factor. Right? So this here has power 2. This here has power 1. This here has power 2. And then essentially when you do this, you take the sum is 5. And that's how I know the power is 5. Right? I'm not going to multiply everything out. Like I just care about the highest powers, right? And that minus 4 in front just comes from the minus 4 that was given in the problem. So you sum the powers, and that's just a consequence of the laws of exponents. So I know that this guy looks like an x to the 5, minus 4x to the 5. So now tell me about the end behavior. How is it going to behave?
One end will be pointing upward and the other will be pointing downward.
Right. So it's because it's an odd power. So one side is going to point up, one side is going to point down. How do I know which side points up, which side points down?
The left side is up, the right side is down because it's -4.
Right. So I know it looks like that. And you'll notice that this agrees with our graph from the last part. This agrees with our graph. Notice that it also agrees with the fact that when I tested the left side, I knew we were supposed to be up here. And when I tested the right side, I knew we were supposed to be down here. So if you did the end behavior, you can know what the end points would behave like. You'll know whether it's up or above or below the x-axis. And so you wouldn't really have to plug in numbers. So it would save you some work if you could just look at this. So going back to this position here, if I just looked at this and I realized, oh, that's just a negative x to the fifth graph. So the right side is supposed to go down and the left side is supposed to go up. I would automatically know where these green x's are, right? So I wouldn't need to plug in to figure them out, right? I can just know what they are. Now, if end behavior isn't your goal, you can also skip that step. It's not gonna matter because you can just plug in the numbers and figure out what it is. But the end behavior tells you what position the ends are. So here you can say the end behavior would be as we move to the right, the y value will move down, and as we move to the left, the y value will move up. So that's the end behavior. Very important that you guys learn the concepts because you guys are working a lot harder than you have to, and then you're going to put yourself in a position where you're making mistakes. Which is what happens a lot of times. A lot of times students are like, oh, there wasn't enough time on the quiz. And it's not because there wasn't enough time. It's just that how you're approaching the problem is taking a long time, right? Because you're not just using the right concepts. You're trying to build everything up by reinventing the wheel and actually literally expanding everything. No, if you understand the concept of multiplying out and you understand the laws of exponents that you're just adding the powers, you would know I don't need to multiply out, just add all the highest powers that I see, right? And so while one student is there multiplying everything out, they'll take 10 minutes to do the problem. Another student would just, oh, I'm just adding 2 plus 1 plus 2, and they're done within a few seconds, right? And when I'm writing a quiz, I'm writing it from the perspective that you're going to see it the 2 plus 1 plus 2 way, right? Because I know I've taught you that concept and I've taught you how to apply that concept. So when I'm thinking, oh, I'm writing this quiz, how much time should I give them? Like I'm giving you the timing based on, I told them the strategy, I told them the steps. It's not like they don't know. It's not like I just came to class and randomly did some examples and didn't explain why I was doing what I did. No, I explained why. So this is the strategy. This is what I'm trying to apply. Here's what I'm thinking. Here's what I did, why I did what I did. Right? So it's to help you guys to know how to think about these problems, right? So make sure you know the strategies and the general ideas because they really guide you. So we only have a little bit of time, but again, in terms of functions and their representations, I think I can do both of these at the same time. So we do know. Let's talk about this separately. Functions. So again, most of us have an intuitive understanding of what this is. So remember what a function is. It's a rule that assigns exactly one output to each input. And we know that the set of inputs is what we call the domain of the function. The set of corresponding outputs is what we call the range of the function. The set that holds possibilities for outputs, that is called a codomain. So there's a set where you can choose outputs from, but not everyone necessarily is chosen. The ones that you choose to connect to your domain elements, those guys form the range. Everyone else, everything goes the codomain. We also spoke about representing functions, and we spoke about several different ways. So one was with formulas. All right, so that's like y equals f of x. You know, so example, y equals 1 over x plus 1 is a function. We also spoke about things like functions past the vertical line test and things of that sort. Another representation is we can draw a graph. We can do a table of values. We can do mapping diagrams. We can describe things in words. Right, so you could represent a function in various ways, and we actually did examples of all of those, and I expect you to recognize when you're looking at a function. We can also do like a list of coordinates. Etc. Right? So I think those are the only 6 representations I gave you. And in terms of function operations and combining them, these are just operations that you can do with functions that you normally do with numbers, like add them together, multiplying them together, etc. And we kind of discussed the concept of what it means to like multiply out 2 functions and all that stuff already. So let's say f of x and g of x are functions. We can do things like we can add these functions together. And that just means add the formulas for their outputs. Same thing if you were to subtract them. We can multiply these functions together. You multiply the formulas for their outputs. And we know that if you're parentheses, you have to expand the parentheses, and we already spoke about that. You can divide one function by another. And of course, you cannot divide by 0. Yeah, and we did something called the composition, which again, you've seen this before through things like difference quotient, right? It involves function composition. And this is if you do like f of g of x, f circle g. That basically means f and you put g inside. So this is replace every x in f of x with g of x in parentheses, so you don't mix anything up. So I don't know, example. F of x equals x squared minus 2x plus 1. G of x equals x minus 1. And I could ask you, what is f of g of x? Well, this basically just means I go to x, and everywhere I go to f, and everywhere I see an x, I now plug in parentheses g of x. So it's going to be that squared minus 2 times that plus 1. And so that's going to be x minus 1 all squared minus 2 times x minus 1 plus 1. All right? And we can evaluate such functions. And I spoke about function evaluation as well. So example, I can ask you, what is f of g of 2, let's say? And you'd have a couple ways of doing this. One way is first find g of 2, then plug into f. So that's one way. So you can say, okay, g of 2, well, that's just going to be 2 minus 1, which is 1. So this means that f of g of 2 is just f of 1, which is going to be 1 squared minus 2 times 1 plus 1. I think that's what I mean, plus 1 minus 2 times 1. Yeah. And so that would give you 0. You could also do instead, first find f of g. Then plug in x equals 2. So we saw that f of g was x minus 1 all squared minus 2 times x minus 1 plus 1. And so this means that f of g of 2 just means I'm going to plug in x equals 2. And so, yeah, that becomes 1 squared minus 2 times 1 plus 1. You get 0 again. And I would say this is recommended if you have to reuse f of g, right? So maybe I might have asked you, what is f of g of multiple x's? What is f of g of 1? What is f of g of 5? What is f of g? Then it makes sense to just actually find a general formula first and plug in the x's. However, if I just give you 1 point to find f of g, then you just plug in that point. Yeah. But we'll stop right there. So these are the concepts that you'll need to know for the test. Well, there were some things that we skipped over that I assumed everyone would be fine with. But other than that, this is where we are. So we'll stop right there. Hopefully that was clear and we cleared up any misconceptions, and we'll be good for the quiz next week. So with that said, thank you for your attention. Thank you for attending, and I will let you guys go right now. So take care. Good luck studying for the quiz next week, and I will see you in the next one. Ciao.